can't say the phrase toss some cash. What? I'm bribing you. That's credit points. Oh, this is a well-established practice. Don't worry. And I like to call it bribery, too, because then it feels even more like a good deal. Psychological tricks. Although now I'm telling you, so oh well. Okay, folks, so please, let's pick up where we left off. Chapter 4, Data Files. Know Thy Customer, I believe is the name of it. I can't see it right now. Yep, there it is. Play on words. Know thy neighbor? What's it?
I'm having a problem.
I'm hopefully going to help you.
Okay, now when I go here to this particular data file through D2L that you provided,
Yep.
when I save it to my F drive to practice at home, the data mining field is not there.
Right. Data mining. I'm not sure I've said this out loud. Please, if I may have your attention. The data mining tab is a paid add-in. You can have it on your computer for the low price, one easy payment of, I believe, $25. You get I think it's a 180-day license, student license, which should be the same one as we have in the classrooms here. So, if you want to come to campus, use these computers, any of the labs in this building specifically, the other computer labs, other buildings don't have it. You cannot go to the library and use those computers, like the main library. They don't have it. Because we pay for them in this building. So you can come here, these computers have it. They apparently don't all work, as we've discovered, but most of them anyway, have the software on it. So if you want to have access at home, you don't want to come to campus to work, because I get it, then you can install the student software. And there is install instructions on, I believe it's on the lecture files. I can look. It's not that complicated. You pretty much just put in your course ID, your textbook code and your course ID, which is on the instructions, and then you pay $25 and you're good to go. And that, I do believe, exists both for Windows and Mac now. It did not exist before for Mac, but I believe it's included now. So you can get that at your disposal, but it's $25. So I haven't wanted to talk about it a lot because I've had this in the past, and then students go pay the $25 because they think they have to. It is totally optional. Yeah.
So how many assignments do we have to use the add-ins on this laundry group?
Chapter 4, Chapter 7, Chapter 9, so 3. If memory serves. I think that's right. Yeah. If it's open. Shots fired. Casual fire. It's my Saturday Night. So I think that was an SNL skit, wasn't it? It was Justin Timberlake and Jimmy Fallon. Hashtag. Okay, so the data mining tab. It will only be here if you have paid the money. And if you have paid the money, you can go to license and you'll log in with your student ID and put in your password and it will populate for you. It will work for you. They've changed how this system works, so it's kind of weird, but I think this is better. I haven't had enough experience with how the licensing works to really know for sure. So far you should have opened Know Thy Customer. Now, remember, we don't want to go to this group over here. This is the danger zone, all right? This is bad. This is where you run into trouble. We want to be over here. This is the happy zone, or relatively speaking. Yes. Well, for clustering, both k-means and hierarchical. So we're going to be in k-means clustering. So it's called k-means clustering. So hopefully it should be intuitive that it's found under cluster. Or clustering, what's it called? Yeah, cluster. And then the first option, I think. Or the second option. I don't know. I just clicked it. Aha! I've committed an error. How do I know and what did I do wrong? Okay, well that's what I did wrong. How do I know?
Because it's not showing the names of age.
So, I don't have my variable names here. So, silly mistake. Let's fix it. Click into data, try again. Ah, that's more like it. So, age, female, income, married, children, car, mortgage. Now, some of you complained about the shift click from last time. So if you don't want to shift click, you can do it this way. Click, arrow, click, arrow, click, arrow, click. Shift click looking good now, huh? Click, arrow, click, arrow, click, arrow. Or you can shift click. Your choice. I will be choosing to shift click. You can do whatever you want. Hey, he said it, not me. I'm not sure if I said this out loud. So I recorded this last time, right? And I took that video and put it on D2L. So it's linked for you there if you want to go back and rewatch this video. I'd like to add timestamps to the description. I haven't done that yet. Okay, once you get your data in, you click next. We're going to normalize input data. 2 clusters, 10 iterations, and 10 random starts. And that is about how the instructions will read. It'll say, normalize input data, specify number of clusters 2, iterations of 10, random starts 10, and then usually we'll just leave the set seed alone. That'll be given as a default. So if I don't tell you something, that means leave it at default. There are lots of options you're not going to touch. So the things that I tell you to do will be things to change from the default. Okay? So actually, because there's nothing else in the next tab we need to change, we can just jump straight to finish. Now, this is what we had done last time in class on Tuesday. We had gotten this far. Now, we're going to do a comparison, so I wanted to rerun this report so we can see what we had before. So, before this gets confusing, I'm going to change this title of my tab down here. I want to leave KMC output. That's K means clustering output. But I want to add that this is 2 clusters. So there's several ways that you can do it. It's totally, what's the word I'm looking for? Cosmetic, there's the word. It's totally cosmetic. It just looks nice kind of thing. So name it something that you can remember. I don't recommend just saying like _2. I would say like, I think you could put equals. Let's find out. K equals 2. Underscore K, lots of wrong buttons. Let's try it again. KMC output K equals 2. Can I do that? Yep, it'll let me. Okay. If you don't know how to do that, you can just double click on the tab name. KMC underscore output was the default. I added underscore K equals 2. I can zoom in on this so you can see. Magnify, magnify. It's my Admiral Akbar. Wait, where am I going? Over here. Okay. KMC clusters, K equals 2. Oh. Why are you lagging? No, it's okay. I didn't need this to work. There we go. Okay. So, KMC output, K equals 2. KMC clusters, K equals 2.
Oh, same thing over there.
Yep. Because we're about to have more copies. So, K equals 2 is basically the smallest number of clusters. I don't even know if it'll run with K equals 1 because I've never bothered to check. Why would you care? K equals 1 is useless. Now, so, remember that, man, this is running slowly. At your leisure. Okay. So here's kind of your the most interesting information. So if you recall, we talked about our variables, the cluster centers before, and if the values are close to 0, what does that mean?
Irrelevant.
Kind of irrelevant. That variable is not being taken into account for the cluster. So if I look at age, those numbers are not 0, so those are pretty significant. Female, not really significant. Income, looks like it's meaningful. Married, children, car, and mortgage are all being ignored. So, we have 7 variables, and we're making our 2 clusters largely dependent on the age and income. But, what happens when you stay in a job for 10 years? What happens to your income?
It goes up. Hopefully.
Hopefully it goes up.
It stays pretty steady.
Right. It should be, depending on your job. It can totally depend. Like my job, It's flat. This is how it works. But it starts out pretty high, so it's hard to complain. Other jobs, computer science, engineering, supply chain, whatever, these kinds of things are still pretty good when you start, but then they have a lot of upward mobility. The point that I'm reaching is this. While age does not directly mean that just by getting older, having more work experience, you'll make more money, but there's a connection, right? There's not no correlation. It's just not a perfect relationship. Which means that actually, since I have both high age and high income, what that means is we're really just have one connected idea. Age and then income and age are going to be related. So really there's only one thing that's differentiating these two clusters is what age group are you in? Because the age and the income are going to be coming along a part of that. So, is it exactly 1-to-1? No, of course not. But there's a strong relationship there. So it's important to recognize this. Now, it might be interesting to see, okay, well, we've got specifically the older folks, the older people, and higher incomes, but maybe there are, higher income people that are young that aren't being in the second group or whatever. So let's see how many individuals have been placed into the older and higher earning group. 256 out of the 600. That's this cluster size right here. How many individuals are in the group? 256, which is over a third, right? It's between a third and a half. So, a big chunk, actually. So it doesn't seem like this cluster is just, nitpicking, cherry-picking individuals. So that's good. That's a good sign. If your clusters get too small, then they kind of start sounding irrelevant. Like, okay, there's not really very many people in that group. But in some ways, the smaller the group, you might start knowing more about that individual. So, kind of a pros and cons situation. But the two clusters are both quite large, and there seems like a lot of information is missing, meaning is being ignored, not being captured by our clusters. So we have strong evidence to support that a larger number of clusters, a higher number of K, would lead us to a better clustering group. Now, that begs the question, how much? How much should we use? There's no hard and fast rule. However, a good place to start might be the number of variables. How many variables do we have? 7. You can count them right there. It's at the top of the screen, at the top of the page actually, if you scroll up to the very top, but you can just count to 7. For a small number of variables, just count. It's not worth it. There's 7. So we tried k equals 2, which is like the smallest number. That's reasonable. So let's try k equals 7. It might be too much. It might still be too little. We can't tell from here. So let's give that a go. So let's go back over to our data tab, which, by the way, it's tempting. This happens to a lot of students. I see it. They go, okay, I'm ready to go again. They go straight to the data mining tab. They click in buttons, and then they get the same problem that I started with, where there's no data recognized, and the data mining tab is freaking out. What am I supposed to do with all this crap? You gave me nothing, and then a fight starts, and then you realize, oh, if I had just clicked on the tab over here, we could have avoided this whole mess. So, go back to your data tab. You can't see it because I'm magnified up on top of my screen, but click on the data tab, come back to where you started, click on in here somewhere, and reopen the data mining tab. Go back to cluster. Oh, that's not cluster. That's cluster. K means clustering. And eventually it'll load. Eventually it'll load. Eventually it'll load. There it goes. Okay. Now what'd you notice? What happens? Oh, it's preserved. That's nice. You don't have to go in and type in all the settings again. So all we have to do is click next. Oh, and all of these are the same. Well, that's just dandy. Isn't that swell? So, let's try k equals 7. Which, by the way, usually problem statements do not say use 7 clusters. They're often given in that format. Use k equals 7. Writing, it's much more compact. It's almost harder to say, but written down, it's a lot more neat and compact, and it's the more rigorous way of doing it. So expect that. I'll try to say it out loud so that you get accustomed to thinking of it that way. K equals whatever means number of clusters. This is often mistaken, often forgotten. Okay, that's all I changed. I opened the data mining tab. I clicked cluster. I clicked k-means cluster. I clicked next, and I changed number of clusters from 2 to 7. K equals 7. And now I'm going to hit finish. It ran the report faster than it loaded the wizard. Yay, Excel. Oh, jeez. Okay, that's what it is. All right, so if you want to review the inputs, I brushed past this, but there is a summary of inputs. If any of these things you want to verify that your settings were correct, you can look for each of these things that was listed in the problem description. You can look for it here, make sure you did it correctly, which is also useful if you don't rename your tabs as you go, and you come back later and you're like, what the heck does this mean? This is where you go. This is the biggest reason to have this, actually. Double checking your inputs is always a good idea. But then if you run the report like 6 times because you realize, oh, I made a mistake, and you don't label stuff, this is how you're going to save your life. You've heard the song How to Save a Life? This is it. What'd you forget? Normalize?
Normalized class.
See? I'm telling you, it helps. Yeah, Tony.
Is there a limit to clusters?
Probably. In this software, I don't know what it is. Let me put it this way. I haven't run into it yet.
Don't imagine we're going to have an assignment where we're going to have to do more than like 20, but...
No. I mean, and the thing is, the more clusters you have, the harder it is to analyze. You can. It's definitely possible, and there's certainly occasions for it. But we can work on concepts and demonstrate that you understand things with smaller problem sizes. So for our case, we won't bother. But I'm sure there's a limit, especially in Excel. Remember, Excel, this stuff works. There's nothing wrong with it. It's just not efficient. It is laughable how much more efficient real statistical software is than something like this. But this is Excel, so you can actually get it. And it's a lot more user-friendly than some of those faster things. So that's the trade-off. Because we can run a report in Excel a lot faster than I can teach you how to program and run it in R. The upfront of the learning to program is a lot slower than just stopping it in Excel. So that's why we're doing it this way. I complain about the speed, I make fun of them for it, but that's why. It's a lot more user-friendly. And you have higher access to it. So, okay, so you get your trues figured out?
Yeah.
Cool. True that.
How many clusters we ran the first time?
2. Oh, that's a good reminder, actually. Hold on. So, you see what happened. We got our original tab names back. So, you have to keep remembering to change your numbers here. So, let's add this to k equals 7. I got distracted and forgot to do it.
So if you don't label it, will it just keep labeling it the same?
Excel will not allow you to have duplicate tabs. There's an implicit structure behind the stuff that you can't see. And so if you have duplicate tab names, it would have duplicate cell references and it would explode, metaphorically. So what will happen is it'll add underscore parentheses 2 parentheses on both of those, and then you run it again, you'll get 3. Run it again, you'll get 4. I think it skips 1, which kind of irritates me, but that's how it is. So it won't explode. It won't let that happen. But it will be very confusing. Okay. So now that I have my coffee, I'm ready to watch radar. Now that I have my tabs renamed, I'm ready to look at my new clusters. Where is it? Right here, sir. It does not have to be this slow, I'll tell you that. Okay, now with k equals 7, we can't see everything at once, so we'll just focus on cluster centers for now. Okay, as I promised you, this is a lot harder to look at. K equals 2, it's very easy to compare and contrast. There's 2 clusters. This one, that one. That's it. Now we have 7. So just go one cluster at a time. Just like a mouse eating a large piece of cheese, always start from the top. or the bottom. I don't really care. I personally start from the top. You knock yourself out. The order does not matter. These clusters are arbitrary. They don't mean anything. This is not like, ooh, cluster 1, cluster 7. This doesn't exist. It's just a number. It's 1, that's 2, that's 3. It's kind of like if I went year 1, year 2, year 3. That isn't my preferences. Year 1, year 2, year 3. Right? I had to stop in the middle, like, which one's better, 3 or 1? I don't even know. It's arbitrary, right? It's just wherever you started from. It doesn't actually matter. So, don't read into that too much. Okay, who wants to take a crack at cluster 1? Let's start with age. What does cluster 1 age mean? Not all of you at once.
Third most relevant thing.
Third most. Where'd you get that from?
Just going across which one's closest to 1 or above 1. So
Oh.
it's married, female, age.
Okay. Interesting. So so married, then female, then age. Okay. So we have two things that have larger absolute values than it. So is that still worth considering? 0.71? I asked him.
Maybe, yeah.
Maybe, yeah. I'll buy that. Sure. There are two things that are more important, especially married. Negative 1.39? In fact, let's just glance. Do you see a bigger absolute value anywhere on this chart?
So it doesn't matter if there's a negative sign in front of it?
It does make a difference. But it's still... So the question of, do I care? Positive and negative doesn't matter. What does it mean? Positive and negative means everything. Is it above averagely large? Like, is this specifically people who put 1 a whole bunch of times, positive? Or is it people who put 0 a whole bunch of times? Those are negative values. So in this case, married, negative 1.39, means single people. This cluster is made up potentially exclusively of single people. Of singles. Yes, Tony.
Mine's very different from yours. For age cluster 1, I have 33.05 for fiber feeding.
So, because of the set seed, we should all be getting the exact same answers. So if we didn't, and there's something... So say the number again. What'd you get?
33.05 for fiber feeding.
Okay. So, I bet that if you scroll up to the top, you'll have the same problem up here where you did not check the normalized input box. So, scroll to the top. We'll do it together. Scroll to the top. Right here. The last thing right before random start summary normalized reads false, doesn't it? So, go back into your data mining tab and go back to the second tab. Step 2 it says, and check the box for normalized input data, rerun it.
Should I delete the 2 right now?
Check both your k equals 2 and k equals 7. This is another good point, by the way. If you realize a mistake, like 2 or 3 tabs in, you probably made it from the very beginning. And you're going to have to go back to the start all over. You remember when I made that big deal about checking your work as you go? This is why. No flame. This is a learning opportunity. Because if it happens to you now, not a big deal. Happens to you on the exam, bigger deal. This is a good time to make mistakes. Because you learn from them, hopefully. Okay. Okay, so while Tony's getting that sorted out, I'm going to choke and then hopefully undie. Gotta hydrate. So, all right, age, negative 0.7. Above 0.5 is where I'm really pretty convinced that something's worth noting. 0.3, 0.2, maybe. But there's probably something that's more meaningful. And if not, then you might have too many clusters. We'll see if we're there yet. We'll see if we're there yet. Okay, cluster 1. Single people. All right, we got single. Female. Now, if female is labeled as 1, what does that mean? This individual is female. So that's the catch.
Yes.
Usually, or it's more common for it to be labeled as male 1 or 0. It doesn't matter at all. It's just a yes or no question, which again, I didn't make the form. All right, that's just how it's labeled. Okay. In this way, it's binary. I'm sorry. It's just how the question's written. So don't see me.
Okay, so then male is female is what?
So imagine a question. Do you identify as female, or were you, whatever? If you say yes, that's writing a 1.
Okay.
I haven't asked you your pronouns, but I'm assuming you'd say no. So you would
0.
indicate 0. So that would mean we have single not females, which actually, by the way, you remember when I told you before that Jacquard's coefficient, that thing where we said just saying 0, maybe I'm not matching that person after all. Because I would say no to being female. And so might a large number of other people, but for different reasons. They might be non-binary or some other gender, and they don't identify as female, but they also don't identify as male. Or maybe it's because they use different pronouns, or some mixture of the two pronouns that they would choose a 0 as well. So that's the danger with binary variables, is not female doesn't mean male. But it's tempting to think that. And also, you have no idea how is this data recorded, how is the question asked. It may be that the person asked them, are you male? And if they said no, they wrote down 1 for female. You have no way to know. So it's very difficult. Even with data, you always have to be careful about what it means, and being very careful about your interpretations, because you never know where it came from. So one of the things you can do is go find out where it came from. In a textbook, in a class, that's hard. But generally speaking, general advice. Anyway, so we'll just say binary context, female. Oh, we'll say non-female. We'll do it that way. So single, non-married. We'll say non-married. Because, a person might object to being single. Like, I'm engaged. Perhaps. I'm not, but could be. So, I'm not married yet. I'm about to be, So, yeah, non-married, non-female, non-old. I don't know. That's a numerical value. That's an age. So below average in age, compared to whatever the age is. That's another danger. Maybe this is specifically an age group of 55 to 60. It's not, but it could be. So you'd have to go back to your data to see what those numbers actually mean. So you might say things like relatively young would be a good way to say that. So you have non-married, non-females, relatively young. Income, relatively lower income. Pretty close to the age significance. So, okay, still 0.6 is meaningful. Okay, so relatively low income. 0.14, that's negligible. I think you can probably ignore that. So children's not being taken into account, car, mortgage, same story. So those 3 variables, not really a factor in cluster 1. Cluster 1 are defined by relatively young, non-females, with relatively lower incomes, and are non-married. We can go into the clusters and actually check. It'll tell you what observations are in which, so you can actually go and find out if these are all non-married, or if there's exceptions, if you care, but that's generally the rule. Okay, cluster number 2. Let's go ahead and throw out children in a car. Those are not being taken into account, right? Okay, what's our biggest number? Biggest absolute value?
Female.
I agree, female. 0.99, 9, it's basically just -1. Okay, so largely non-females. So similar amount of females or non-females as cluster 1, so that's kind of interesting. So there's some overlap in terms of the female variable here. They are both significantly non-female. That's a sign we may have too many clusters. Okay, let me say that again, because the room got quieter as I said it, which means you weren't listening at the first part. 2 variables with, I'm sorry, looking at the wrong ones. These 2 are actually identical. They have exactly the same number of non-females in these 2 clusters. These two clusters have a very similar number of non-females. So, looking at the first 3 clusters, ooh, and the last one, 4 out of 7 clusters have a lot of overlap on the female category. And it's a significant, oh, I'm sorry, that's a negative number. So, negative and positive. Aha, I wasn't paying close enough attention. This is important! Don't make that mistake. So, negative, positive. So you have the same number of non-females in cluster 2 as you have females in cluster 3. Interesting. However, cluster 1 versus cluster 2 have very similar number of females. So it might be that we could combine those 2 clusters. Or you could have sort of like a supercluster and just know that they're differentiated. So these are all the non-females are in cluster 1 plus 2, whatever you want to call it. Cluster 12, to be really confusing. Don't do that. Cluster 1-2, something like that. And then they're differentiated into cluster 1, cluster 2, based on other characteristics. You could think of it that way. It's really confusing to write it that way. So that's a sign you may have an extra cluster. One more cluster than you need. Looking at the other variables, there's not a lot of overlap, but both are kind of in the young group. So it looks like you really have one major cluster of non-females broken apart by the other 6 variables. Well, I guess 3, because 3 of them are ignored. But okay, so there's starting to be kind of a hierarchy we can see here. Okay, what else do we have? So we have non-females. The married group appears to be in cluster 2. Non-married is in cluster 1. Okay. Children, car, still ignored. Mortgage, non-mortgage, seem to be in cluster 2. Okay. Interesting. All right, cluster 3. Age is kind of ignored. We've got a large proportion of females. Average income, a little bit above average on the married side. That seems to be relatively inconsequential, right? 0.37, 0.38 rounding. That's in that wishy-washy area. No children, because it's a negative number. Slightly below average on car, but not significantly so. And, identical number of mortgagees, or lack thereof. Yeah.
I was just wondering, is there a way, or when we're doing assignments, do you want it to look like that, or is there a way we can clean it up to make it not so many discipline points?
Oh, you can definitely clean it up. All you have to do is click and drag, and then go up to your Home tab. I'm going to go 3 decimal points. I feel like we need... Why not? We'll do that many. 2 decimals. These are z-scores, so 2 decimals is very common. This is the level of granularity provided on a z-table. So using 2 decimal points is a generally good idea for z-scores. For standardized values, 2 decimal points is accepted standard. And that's enough, right? I'm generally segregating based on the first digit. 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. More meaningful, right? So 2 decimal places is plenty. And that might be helpful to you. I'm lazy, so I'm efficient with my keystrokes. I like to be lean when possible. Especially if you're going to look at like 8 different choices. Do I want to reformat all of them? Maybe. Or you can set up a macro for it. I've done that before. So you can record a macro of you reformatting it the way you want it, and then you just run it on each tab when you get it. It's an option. So, in fact, you can get really crazy where you can even, you can set up a macro where it will make new tabs, type in for you the new value in the number of clusters. I think you can do this. Run the report, rename the tab, and do it again with all the reformatting and stuff. But it's more work than just running the report 4 times. So, but if you're going to do it a lot, it might be worth it. So I wrote a macro like that for my vocab quizzes. It reformats my pages based on how many words I choose to give you on a quiz. I'm doing 10 every time, but maybe I'd want to do more. Maybe I'd want to do less. And so it'll reformat and adjust the print areas based on that with macros. So there's a lot of cool things that behind the scenes that Excel will do, which is part of why it's so slow. It's got all these other things in the background that we do. Okay, anyway. All right, so cluster 3, we've got females, more married than not, more non-children than not, and no mortgage. Okay, but again, we've got a duplicate. So these are basically like people without a lot of mortgages, and then differentiated. I mean, like that's similar. That's different. Okay, so no non-children down here. But this is even, so not children isn't enough to bring you into this cluster on its own. Marriage's pretty similar. Income, a little bit lower average in that group. But gender, reporting on the gender of one, seems to be very significant. So this is the process. You can go through and you can say, well, I have a lot of stuff that's overlap, but overlap isn't bad. You can start to understand relationships in the data, right? The hierarchy of the data. Ah, I can do this, or I can do that, or I can see these connections. So, you might decide this is good. So this is the process of going through. Okay, older folks, gender's pretty even. Wow, making the big bucks. Not that meaningful. Have children, probably have a car, maybe, but maybe not, and no mortgage. So this is what I want you to get to. It's really as simple as, is it a big number, absolute value? Is it at least like 0.3, 0.4? If not, ignore it. If it is bigger than that, then it's worth mentioning. But then temper your adjectives, or I guess adverb, very big, kind of big, based on the absolute value. And then if it's positive or negative, know what that means. And then hopefully this will get to be, you can just glance at it. It should be like, okay, below average, female, lower income, kind of single, definitely probably children, nothing, low mortgage. You do have to keep looking at the column titles, because I forget what they are. But you should, with some practice, still pick up on what the cluster centers mean. Is that starting to make sense? Starting to be comfortable? Mostly yes. Okay. Now again, we have this k-means cluster didn't converge, which is an issue, but we're going to look past it for now. Okay, inter-cluster distances. Now you may be thinking like, man, I think these two clusters are really similar. Here's how you can check. So one way to answer the question, do I have too many clusters, is to look here in these inter-cluster distances. Because the closer they get to 0, the less meaningful the differentiation in clusters is. So, how much is a lot? Well, that largely depends on if you're normalizing your data, for one, but also how many variables you have. Because the more variables you have, you're going to have an additional component of distance. So it'll get larger on its own. So, big numbers means that the clusters are quite different. Right? They are far apart. The cluster centers are far apart. If the numbers are small, then that means they're close together. Now, you can ignore this diagonal of zeros. Why? What is this? What's this number right here? What is it?
Cluster 1 to cluster 1.
The distance from cluster 1 to cluster 1. How far away am I right now from myself?
I mean, you could answer that question.
Maybe I'm scared of having Antavis tell me what he thinks, how far away I am
Not
from
you,
myself.
but people.
Right.
Some people.
Some people. Yeah, I think there's a word for that. Yeah.
Okay, so now when you say in the intercluster distances, it's important to understand how to read these numbers as how close and far they are together.
That's it. I mean, that's the highlight. If they're far apart, then those clusters are really different. If they're close together, they're not different. And if they're small enough, then that's telling you have a redundant cluster, that there's no reason to have separation. So if you put in a big enough k value, you will have clusters that are right on top of each other. It's going to happen. But I don't see anything below 2. Am I missing something? Anyone? What's the smallest number you see? 2.2 something, right? Oh, here's a 2.1. So a way you can check this quickly is you can click and drag, and then if you look at the bottom, you may have to have this configured, but you see this down here? Bottom right of your screen, there should be quick stats. Sorry, Max, can't do that, can you?
Oh, no.
You got it? Okay. So, minimum 0. Rats. Okay. I think I can go in and delete these out, and it won't explode. Oh. Okay, I think that's good. Now, I need to reselect my data. Now that it's non-numeric, I think it'll be skipped. Aha! There we go. Let me move my cursor over more. How far down can I get? Minimum of 2.12.
Mine just shows an average.
Okay, if yours doesn't have that, you should be able to configure it. It does not require administration privileges. You just right-click on this bar. And then there's going to be a bunch of choices. And then you just check the one you need. I know, right? It's cool, right? Yeah, you're welcome, right? Well, people never show me anything like this. Yeah, what's up? I deleted those. Yeah, it is.
Mine says 0.
Well, mine did too. So, the delete key?
Oh, you're using okay.
Yeah, I know.
Yeah. But there's like a shift click or something.
You know there is, actually, believe it or not. So shift click, I think, or no, it's control click. Control click is a way of doing array formulas, which are a giant pain in the neck. And I don't want to explain them. I don't really understand them. I can kind of make them work, but they're a hot mess. It's a way of doing like fill handle formulas without making fill handle formulas. It's a hot mess. Okay. Oh geez. I messed up my zoom. Oh well. So, looking for small numbers, I don't see anything, so actually it looks like I don't have too many clusters, so I could even consider going more. At some point, you just have to call it good enough, and there's not a lot of point in getting like the exact right number. Now, what I will ask you questions on an exam. All right, you hear me? You listening? I will ask you questions on the exam that say something like, which number of k do you recommend? I don't really have a right answer in some cases. I just want to see what you think. And if I agree with your logic, you'll get full credit. Which means, if you go to the first one, and you're like, I like k equals 2 because it's easy.
That's my logic, though.
I mean, so if, like, imagine if you go to your boss, and he's like, okay, so what did you, A says to you, so what did you decide? What's your, what clusters did you find? Oh, I just used. I got 2 clusters. They're really easy. Really easy to understand. He might not like that. Just he might not like that. It's just recommendation. You put a little more thought into it than that. I would give you some credit because you're not wrong. It's just not as complete of an answer as I would like. I'd like to see something like, oh, well, my cluster distances look good. I have some overlap in my cluster, which means I probably have, a reasonable number of clusters, but I don't have too many because my cluster distances are all relatively large. There aren't any small intercluster distances. Okay, let me say that again. In summary, now you should maybe say more than this, but what I want you to say in short, you can be more specific in other words, is basically I have some overlap in my cluster centers, which shows that I'm starting to have some overlap in the clusters, but I don't have any cluster distances that are really small, which would indicate duplicate clusters. In this case, k equals 7 is probably too small, but we haven't looked yet, so I don't know. And we're running out of time, so we need to move on. But this is really the indicative portion. K-means clustering is, I think, the most useful, so I want to spend the most time on this. Is everybody relatively happy? We're getting it? Okay. So that's the process. We would need to keep going in an actual problem, but that's the idea. Okay, so next up, we're going to compare this.
So go back to the data tab.
Yep. To our other choice for clustering, and that is hierarchical clustering. So you know how I said things like, oh, you can start to understand the hierarchy in your data. Well, if that's what you want, here's your tool. I don't mean that sarcastically, like genuinely. There's value in that. Because, so take this for example. How do you think they design websites? Key information and differentiators, right? Like, what department are you looking for? Hardware. Okay, what part of hardware? Tools? Or, I don't know what else. I'm making things up as I go. Right? Paint, sure. And you can choose from those options, right? And so you drill down to what specifically someone's looking for. And so your clusters can be designed this way. Where you have like, okay, I know one thing about you. You are in this category or that category. You know, married or single, legally speaking. Okay, I know one thing about you. Now from there, so I'm going down this fork of the trail, right? I'm taking the my right, your left trail. Okay, now, how do you relate on this variable or something like that? And so you can split and go like that. Now what I'm describing is really a higher order of hierarchical clustering, which we won't see in this chapter. I believe it's in 7. Pretty sure it's in 7. Might be in 9. Can't remember which one's which. Anyway, you'll see it. Those are really cool. Tree networks are really useful, and they're really like an application of this. So we'll get there. For now, let's move over our data. I'm going to use shift-click. It's going to lag. Hold on. Okay, we're getting there. Now we have raw data, or we have a distance matrix. And in fact, you have a little blurb down here telling you which one to use. Now, of course, in practice, again, meaning for us in the classroom, not really in practice, in the classroom, I will just tell you which one to use. True dramatic fanfare. So, if the data is provided in row format, cough, cough, that's what we have here. Select raw data. That's what we're going to choose. If distances between items are provided in a matrix, select distance matrix. That's not what we have. We have raw data. So, leave that at the default. I just wanted to show you what it was, and click next. So all I do is move over my variables, same old as last time. Aha! So, remember all those distances and linkages and all kinds of hot mess I told you about? This is as far as you have to know them. A checkbox. Well, technically it's a radio button, but that doesn't matter. Checkboxes are square, and you check them inside of them. Radio buttons are a circle, and it fills them with a blue dot. That's the difference, if you didn't know.
Radio who?
Radio button. What? Yeah, you're welcome. It probably won't ever matter to you. But you're right. Life is more complete.
Click the radio button.
Click the radio button. You might actually see it in tutorials or whatever. Then you're like, radio button? Now you know. Circle. I know this from website design, previous experiences. So, normalize input data. That is generally a good idea. There's a homework question where you do it once without and once with to show the differences. Generally, this is the way to go. Generally. Not always. Okay, we've got Euclidean distance. Yep, we're just going to leave it there. I won't even let you touch these. I don't want this data set. Okay, we've got single linkage, complete linkage, group average linkage, McQuitty's method, median method, centroid method, and Ward's method. I don't remember what the book says. I don't have it open, so we'll just say complete linkage. Again, I will tell you what I want. I will specify. I think complete linkage is a good way to go. The textbook uses McQuitty's method a lot, or Ward's method. They're just more sophisticated. We didn't talk about them because they're complicated, but they're good methods as well. I think we can hit finish, right? Yeah. Okay, just leave these alone. If I give you other options for dendrogram cluster membership, those can be configured here. But if I don't tell you anything about that, then simply hit finish here. Okay, I'm going to zoom out so we can see this a little easier. Actually, wait. I jumped the gun on that. Okay. So, aha. Now notice our prefix changed. HMC. Output. HC, dendrogram, HC clusters. I'm not sure why I went in that order. I guess it was closest to far for me. It was near, then far. I can't sing a high note. Sorry, Celine. Yeah, somebody else can. It's a great song. Okay, so we could choose to rename these, but we only have one hierarchical clustering anyway, so we'll just leave it there. Like I said, we have the output, which we have like clustering stages, and you know, it's all your raw data or whatever. I generally will stay away from that. Okay. You have like clusters and subclusters and all kinds of great stuff. I generally recommend you hop to, oh geez. Building dramatic tension.
What did you do?
There it is.
Hey! That one.
How'd you do that?
I clicked on the dendrogram chart. Come on, you guys remember 368? Doing everything by hand? Huh? Huh? Aren't you glad it's over?
Mine don't look like yours.
Did you normalize it?
Did you normalize it?
Huh?
Did you normalize your data? If your thing doesn't match my thing, ever, go to HC output. Oh, in this case, HC output, but check your input parameters. Now, in this case, you know what your output's supposed to look like. You may not always get that. I went back to the HC output so that Antavis and I could compare our output to see what he did differently.
From there, what did you click on?
HC dendrogram. It's not zoomed in anymore. I expect it to be all the way over here. The dendrogram. It's just a fun word to say, isn't it? Dendrogram. It sounds like a complex shape, which I guess it kind of is, but like a dodecahedron. That's my favorite one. Dodecahedron. I think that's it. Isn't that a 20-sided like ball cube thing? It's cool. I like it. So, remember that our data was given in clusters before. Right? So if I go back and I look at my clusters, then I will see, cluster, record 1, cluster 1, cluster 2, cluster 2, cluster 2, or whatever. And then by looking at my dendrogram, I can see, cluster 1, cluster 2. Now they're not going to be in order. Why are they not in order?
Because of the distances?
Yes, yes. Because of their distances, because we're looking for the ones that have the closest match. So they are arranged in a way that I can clump them, tournament style. If that visual makes any sense. If it doesn't, you can ignore it. Like this, right? In order for them to clump, you can't have them crossing each other. That wouldn't make any sense. So we just swap them around. So that the hierarchy makes a whole lot more sense. Let me move this magnifier out of the way.
So before you said cluster 1 and 2 would be the closest, but this is only 3.
Well, they're different clusters now. Remember, these cluster numbers, well, 1, they are arbitrary, but 2, this is a completely different approach to clustering. Completely different. So, while our output will be the same, like yours to mine, our output will be very different from the k-means clustering. And that's the whole point, actually, is that this is very different. So, what do we see? Well, we have a distance of 5 on our closest clusters? Now, in fairness, I don't actually remember what k-means clustering, what that, I need to look at what algorithm they use for calculating distance. But if it's not complete linkage, it might be McQuitty's. I want to say it's McQuitty's or Ward's. I need to look. But our distances between the clusters are a lot higher. wonder if it's centroid actually. I used to look. But our cluster distances are high. So it kind of seems like all of our clusters aren't that close together. But it should be interesting. What do you see? That once you hit this first tier, they can be clumped together pretty easily. So that makes it look like they're pretty evenly dispersed in the data. Oh, okay. That's kind of a good sign. So what does this give us? It gives us a relationship between the clusters in a hierarchical format. So this is connected to that, which is connected to that, which is connected to that. But it makes it a lot harder to see what makes a certain cluster what it is. So interpreting the results straight away is a lot harder. So you see behind it, I know we're running out of time, so thank you for your patience. We got 1 more minute left, so give me that 1 minute, please. So you got all these subclusters on the side. Okay. These are just cluster labels. This doesn't give you anything else, I don't think, at the bottom. Oh, there's thousands of records. Never mind, let's not do that. And this is just clustering stages. It tells you what was clustered when as you go. So you get a lot less granularity in your clusters, but you get more nesting of the clusters. So what's valuable to you? Depends. So we still have one more thing to talk about, and I guess we'll get to it on Tuesday. So have a good weekend.
So are we still dealing with chapter 4?
What do you mean? On Tuesday?
I was still interested. You said once you finish with chapter 4, that's on the homework.
Yeah. We're going to do homework on Thursday because we need to keep moving. You've seen basically all of chapter 4. So do the first 2 questions. You'll have 1 left over.
So the homework will still be due next Thursday?
Yeah.
That's what I was trying to figure out.
Homework's going to be due Thursday still, all right? This is the hard part. The association rules will go quickly, I promise.
No signing.
Oh, dang it. I took it out and put it in the way so I wouldn't forget. And then I put it back in my bag because I'm useless. Come sign in on your way out. Thank you.
No, what else do you pull that up other than that?
That's it. That's it.
I don't work on that.